Hi students, welcome in chemistry classes. I am Priyanka Jain and you are watching the videos of thermodynamics. In our last lecture, we have studied about the isothermal process and we have seen how we can find out the internal energy change, enthalpy change, work done or heat transferred in an isothermal process. And I have solved several numericals. Hope you all like that videos. Now the next thing that we have to cover is the graphical representation of work. It means if we have given a graph, generally it happens in the question papers, you have given a graph and you have to find out the answer of the question. It means you have to find out the work done in the process. Now how to do this type of questions? For this, the answer is here. Okay, I am solving this type of question. So see here this video so that you can understand all the theorem very clearly. Okay, so let's start our lecture. First of all, see here which type of graph you will use when you have to find out the work done in an isothermal process. Okay, so for this process you will have to use a PV curve. PV curve means when a curve is plotted between the pressure and the volume. Such type of curve is called PV curve. Okay, and this will look like this. Okay, this type of curve you will get in an isothermal process. Actually, you are getting such type of curves for the isothermal reversible process. Okay, you get the curves for the reversible process. For the irreversible process, you are not getting the curve. Okay, I am giving you the reversible and irreversible process both in the same video. Just relax. First of all, understand about the reversible process. Okay. So for the isothermal reversible process, whenever we have to find out the work done, we will use the PV curve. It means the graph between the pressure and volume. Now we are getting such type of curve. The area under this curve, it means this area. See here, this is the P1 pressure. Okay, this is actually expansion process. The system is undergoing the expansion and this is P2. Okay, and here this is V1 and this is V2. Okay, so the system is going from P1 pressure to P2. Okay, and in this process the volume is changing from V1 to V2. So we are getting a curve like this. Okay, so the area under this curve, this area that we are showing by the green lines, this is the area under the curve that you can see here. Okay, in this manner. This area will denote the work done in this process, work done in the reversible isothermal process. Okay, so if you have given any curve, you can find out this area and you can calculate the work done. See here, I am showing you one of the example. See here, suppose we have given this type of process and we have to find out work done. What is the work done? Question is this. For this, first of all, what you have to see, you will have to see the pressure terms. You will have given here the pressure. Okay, suppose at this point, this one point, at this the pressure is 1 atmosphere. Okay, and at this point, you can see at this point the pressure is 3 atmosphere. Okay, now see the volume change at point 1. Suppose the volume is 1 liter. At point 2, suppose the volume is 5 liter. And at this point 3, suppose the volume is 10 liter. Okay, now you have to find out the work done in this process. So what you will see? You will see this area that you can see under this 1, 2, 3 curve, this one area you will have to find out. Okay, now how you can find out this area? For this, first of all, you will find out the area of this region, this rectangle. Okay, first of all you will find out the area of this rectangle number 1. Okay, then you will find out the area of this rectangle number 2. Okay, and then you can find out the area of this triangle number 3. So first of all you will find out the area of 1, then 2 and then 3. See here, area number 1. For area number 1, if you know the this length into width, If you know, you can find out. So see here, this distance will be equal to 1 atmosphere. Okay, so 1 atmosphere into this distance is equal to 5 minus 1. It means 4 liter. So this will be equal to 4 liter atmosphere. This is the work done in this process. Okay. Now see the area of 2 is of 2 number rectangle area. We have to calculate. So see here, this area, this width is equal to 10 minus 5 equal to 5 liter. Okay, and this length will remain as it is, that is 1 atmosphere. So this area will be equal to 5 into 1, it means 5 liter atmosphere. Okay, now you have to find out this area, this triangle number 3, area in the triangle number 3. So this will be equal to half base into height. Okay, so you can see base is equal to 10 minus 5 liter. Okay, and height is equal to 3 minus 1 atmosphere. So this will be equal to 5 into 2. It means 10 divided by 2. It means 5 liter atmosphere. Okay, so the total area will be equal to 4 plus 5 plus 5. It means this will be equal to 14 liter atmosphere. And this will be the work done in this process. Okay. Actually, this is expansion process, so you can write minus 14 liter atmosphere. So in this way, you will have to find out the work done in any process if you have given the graph. Just you have to find out the area under the PV curve. You can find out the work done. Now one thing should be remembered here. Just only remember this thing that you can use only the PV curve. PV curve. Okay, only the area under the PV curve will be used as the work done. This denotes only the work done. Suppose you have given the curve between P versus 1 upon V. Okay, or you have given a curve between PV and V. Okay, this type of curves you have given, then you cannot use them for the work done calculation. You cannot calculate from this the work done. Okay, only you can use this curve for finding out the work done. See here. Suppose you have given this type of curve between P and 1 upon V, then you will get a straight line. But area under this straight line, if you suppose that this area is work done, no, this area cannot be equal to work done. Okay, similarly, if you have given a curve between PV and V, then you know that PV is a constant for the ideal gas. You will get a straight line like this. Okay, so area under this line, if you suppose this area will be equal to work done, no, this area is not equal to work done. Okay, from this you cannot calculate the work done. Now you will need the formula. Okay, you will need value of V, and then you will have to use the formula that I have given you in the previous lecture. But you cannot use graph for finding out the values of the work done. Okay, now see, I want to tell you one of the very important thing. See here, we are seeing here the reversible process. Okay, what is the difference between the reversible and the irreversible process? Okay, if you have given both type of processes, then how you can identify between them? Okay, see here, in both the processes, graphs are different. You get graph only for the reversible process. See here, suppose this is the PV curve, you will get a graph like this. Okay, this is for the reversible process. Okay, now the area under this curve. Okay, this area that I have told you, this area will denote the work done in the case of reversible process. Okay, this is the work done in the reversible process. Okay, now suppose system is going from the pressure P dash to P double dash. Okay, and in this process the volume is changing from V dash to V double dash. It means this is happening the expansion. This is the expansion process that we are seeing. Okay, if we are seeing the irreversible process. For the irreversible process, we will have to see the external pressure. Okay, we know in the irreversible process there will be a constant external pressure, and one thing you should remember that this external pressure is always lesser than or equal to the P double dash. It means final pressure. It means this external pressure is always lesser than the final pressure. It means suppose this can be here. This is the P external. If we are showing the irreversible expansion in the same graph, then how we can show it? See here. This is the P external that will be always lesser than the final pressure. Okay, suppose it is here. Then if we want to show the irreversible process, then this will come here. This line. See here. The area under this line. Okay, this green line, the area under this line, this will show the work done in the irreversible process. So this is the work done in the irreversible process. Okay, and this whole was the work done in the reversible process. From this you can see that this much area is more in the case of the reversible process. It means we can say that the work done in a reversible expansion, we are talking about the expansion. Okay, so we can say the work done in the reversible expansion process is always greater than the work done in the irreversible process. Okay, in the irreversible process, the work done is always lesser than the reversible process. But if we are carrying out the process in the multiple step, this we have carried out in the one step. We have just put here a external pressure and we have done the process. Suppose we are putting the pressure in the two steps. Okay, suppose one time we are putting the pressure 1 atmosphere, then we are imposing the pressure 2 atmosphere. It means we are doing the process in the two steps. Then the work done will be a little more. Okay, see here. Suppose this is our system, this is the graph. Okay, system is going from the pressure P dash V dash, pressure P dash and volume V dash to pressure V double dash and volume V double dash. Okay, this is the process of reversible expansion. This is for the reversible expansion. Okay, now we want to see the case of the irreversible process. Suppose we are doing the process in the two steps, two irreversible steps. Okay, so one time the external pressure will be, see here, suppose this is the external pressure, that is P external. Okay, and then we are putting the P external here. Two times we are imposing the external pressure. Okay, so one time we are getting a line here. Okay, then we will get this area. Okay, this area we are getting. Again we are putting the pressure here, so we are getting a line equal to here. So we are getting this much area. Okay, so now you can see we are getting this type of area. It means we are getting this area for the irreversible process. In the first curve, you can see that we are getting only this area. This was the area that we are getting. But here we are getting this area much more as compared to the first graph. It means when we are doing the process in the two steps, then we are getting this much area. This much area we are getting. Okay, this area we are getting more as compared to the first process. It means when we are doing the process in the two steps, then the magnitude of the work will be more. Similarly, if we are doing the process in the three steps, then the magnitude of the work will much more. And if we are doing the process in the infinite steps, okay, then the magnitude of the work will be very high. It means it will reach a maximum value. So as much as we increases the steps, then we are getting more and more work and the process is going much more near to the reversible process. Okay, but in the case of compression, if you are seeing the compression, the conditions are just reverse. In the case of compression, the external pressure is always greater than or equal to the final pressure. Okay, This thing you should remember. Then only the compression can happen. Okay, and the work done in the irreversible process will be greater than the work done in the reversible process. Okay, this will be more as compared to reversible process. And one thing you should remember, as much as we increase the steps in the case of the compression, then the value of the irreversible work done will decrease. So just the condition get reversed. When we use the compression process, the conditions will get just reverse as that in the case of the expansion. We can see here, this is the PV curve and we are doing here the compression process. It means now the arrow will be opposite direction in this way. Okay, the system is going from the pressure P double dash volume V double dash to pressure V dash volume V dash. Okay, in this process, this is like this. So the work that we are getting in the reversible process will be this much. This is the work in the case of the reversible compression. Okay, but when we are seeing the irreversible process, it means we are seeing the irreversible compression, then this will be the P external. We have told you that the P external is more than the P double dash. Okay, so it will come here. So the work that we are getting is this much. This is the work that we are getting in the case of the irreversible compression. So this is the work for the irreversible compression. Okay, so you can see here that this irreversible compression work is always greater than the reversible compression. This much work that we are getting more. This is the more work that we are getting. Okay, and as we do the process in the multiple steps, see here, suppose this is the area that we are getting in the reversible process. Okay, now we are doing the irreversible process in the two steps. Okay, so one time the pressure will be here, this is the external pressure, and the second time the pressure will be somewhat here. Okay, just we are supposing. So now how much work we will get? See here, in this case you are getting work in this manner. First time you are getting this much work. Okay, and the second times you are getting this much work. It means now if you are seeing this first case and the second case, you can see in the first case you are getting more work, but in the case of second you are getting a little less work. This much less work you are getting here. Okay, so whenever we are doing the compression process in the multiple steps, then the magnitude of the work will decrease. Okay, so this is all about the graphical representation. I have tried to give you whole the explanation in a very short and clear manner. I hope you will like this video, and if you are liking this video, please share this video, please comment me, and please subscribe the channel. Thank you.